Okay, so here's my video for section 9.3, which is about graphing quadratic functions. And basically what I'm going to do here is just explain the rules or the steps of graphing a quadratic function. And then I'm just going to do an example and hopefully it's a little clear. This is really something that you just kind of get the hang of the more you practice. And you can always check your graphing by putting these into a graphing calculator. You can always just put y equals, type the problem, and then hit graph. There's also some free programs online that you can check your answers. But here's the steps if you're ever asked to graph these by hand. You need to first start off by graphing the axis of symmetry. Now, your quadratic equation is always going to be in this format, this a x squared plus bx plus c. So here's an example. If I have y equals x squared minus 4x minus 5. And I know, first of all, I look at my a value just to give me an idea, because these functions, they're always parabola. So your general shape is never going to change. It's either going to be like a smiley face or a frowny face. And since this has a positive a value, I know right away that I'm going for a shape that's going to look something like this. And my first step is plotting this axis of symmetry, which you learned from the last section is just x equals negative b over 2a. So I have a b value of negative 4, and it's negative b, so negative 4 would be a positive 4, and then I have 2 times my a value, which is just a 1. So 4 divided by 2 is going to be 2. So my axis of symmetry is x equals 2. And then my next step is to find the vertex. And you find the vertex by plugging this number that we found for our axis of symmetry into this equation. So I am going to have y equals, and I'm going to have 2 squared, because I just plugged that x value in for my x, minus 4 times 2 minus 5. So I'm going to have 4 minus 8 minus 5, and 4 minus 8 is going to give me negative 4 minus 5, so negative 9. So I have that my vertex is going to be the point 2, comma, negative 9. And just a reminder that since we know that it's going to be this shape, that vertex has to be the minimum point. So that's basically going to correspond to this point right here. It's going to be a minimum. And then you're going to find your y-intercept. Y-intercepts are the same thing they've always been. You basically make your x's zeros because you're trying to see where it crosses the y. So you plug a 0 in here, and you plug a 0 in here, and then you're going to have where this would all be 0, this would all be 0, and you have y equals negative 5. Your c value in a quadratic function, your c value is always going to be your y-intercept. So again, though, you get that c value because y-intercepts are where you plug zeros in for x. So y-intercept is 0, comma, negative 5. So this is going to be a really ugly sketch, but what you have so far, which you would want to do nice and neat on graph paper, is plot the points that you have so far. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. All right, so I had to make sure I went down to 9 here because my vertex is -9. Luckily, I also knew that was my lowest point. So I'm going to -9, and that is going to be my minimum point. And then I am plotting my y-intercept as well, which is 0, -5. So 1, 2, 3, 4, 5. So right about here in my lovely picture. And then you find 2 more points that are on the same side of the, like, you basically want them on this. If this is my axis of symmetry, I'm looking for the points that are on this side. So you're just picking random x values over here and finding y. So I might pick a -1. So if I pick -1, -1 squared would be 1. -4 times -1, that would be a +4. And so that gives me 5. And then I have -5 is going to be 0. So another point that I found when I plug in -1, I get 5 for my y value. So I just randomly found the point -1, 5. I know this is kind of hard to see. I just don't have a lot of room to write. But I just plugged a -1 into x, and then I solved it, and I got 5. So, or no, I didn't. I got 0. I'm sorry. Because it was 1 + 4 - 5. So 0. And you might want to pick one more point. Maybe you pick a -2 this time. So again, I'm just randomly picking a point over here. -2 squared -4 times -2 -5. -2 squared is 4. Negative, that would be +8 -5. So now I got 12 - 5, I got 7. So another point is -2, 7. 1, 2, 3, 4, 5, 6, 7. So up here. And that gives you half of your parabola. The last thing you do is you mirror it across this x-intercept. So right here, if I'm looking at this axis of symmetry, which we established to be x = 2, I've basically got this imaginary line going through 2. And since this point here goes through 0, it's 2 away. It's 2 spaces away. So I'm going to put it 2 spaces away over here. And then this point here that's going through this -1, it is 1, 2, 3 spaces away. So I'm going to put it 3 spaces away over here. And you're just doing like a mirroring across that imaginary symmetry line. And so then this one over here was 4 spaces away. So 1, 2, 3, 4 spaces away over here. And you just get a rough sketch of your parabola. You can put arrows indicating it would go on forever. And so that is how you're going to do section 9.3. If you need to see more examples of that, I'm sure you could go to YouTube, look up graphing quadratic functions, and there'll be someone that can maybe have some graph paper where it's a little easier to see. But these are your steps.